Hi everyone, this is Delbert speaking. Today's class we will talk about the seasonal components. In the last class we talked about the trend components, which are useful when the time series has a well-defined trend, but for most applications we need to compute seasonal components because annually or monthly or quarterly the time series has a well-defined pattern. So because of this, the seasonal components are important to model the time series in appropriate way. Okay, so as I told you, we talked about the trend components. We had an introduction to time series, and in this class the seasonal components will be presented. So in order to obtain the seasonal components, we need to take into account the trend components that we've computed in the previous class. In addition to that, we need to observe which model is appropriated for to obtain the seasonal components. We have two models when we apply the classical model. The first model is called additive model. It is additive because we need to sum the components of trend, seasonal, and the cyclic components. And we have the multiplicative model, which uses the trend multiplied by the seasonal components multiplied by the cyclic components. As I told in previous classes, we will not consider for this application for our activity in October the cyclic component. It is important, but it is necessary to have a long-term data to apply the cyclic component in appropriate way. Okay, but I will show how the additive model and the multiplicative model work. And then finally, we hope that the model would be similar to the time series data. The model reproduce similar results to the time series data, and with an error, which is the difference between the time series and the results obtained by the model, would be as smaller as possible. In addition to that, we hope that this error has a constant average and a constant variance. So in this case, we can guarantee in certain way that the model is appropriated for long-term applications. Okay? As an example, let's consider the monthly electricity consumption in Brazil for the last 5 years, from 2012 to 2016. So we have a set of data which defines the time series, and the first thing that we need to do when we have a set of data and we want to model it by using time series theory, we need to put it graphically in this way and try to analyze the patterns of these time series. For example, we need to analyze the trend of these time series, or we need to analyze the seasonal or the seasonality of this time series. For this case, as we have used monthly data, we can put it in a year, the 5 years in 1 year, and analyze the pattern of this time series. For example, for this case, we can observe that in June, usually we have the smallest values of electricity consumption, and in March we have the peak values. So the valley of this time series usually occurs in June, and the peak usually occurs in March. And then we have another peak here in October. And this is, in certain way, describes how this time series works. And what we want to do is try to capture this behavior and translate it by the seasonal components. Okay? There is an algorithm to determine the seasonal component, and this algorithm is used to obtain the indexes of the seasonal components. And let's see how can we obtain the seasonal components of a time series. First, we need to compute the moving average of the time series. This is an important step because when we compute the moving average of the time series, we deseasonalize the time series. So we can observe the time series without the seasonal elements. And based on that, we can compute the seasonal components by applying the difference between the moving average and the original data, or by dividing the moving average by the original data. So in this way, we can capture the seasonal components. After that, for even numbers, if you have an even numbers where we computed the moving average, we need to centralize the moving average, and I will show how we can do this. Third, we need to compute the additive and multiplicative model components after the moving average computation, and by using difference or dividing the moving average for the original time series data, we can compute the components, the seasonal components. After that, we need to adjust the additive and multiplicative component. Compute the trend component exactly the same way that we did in the last class. So we have the trend components, we have adjusted the seasonal components, and then we can compute the final components without the cyclic components. Okay, let's see how we can do this by using the time series presented for the electricity consumption in Brazil in the last 5 years.